All right. So, as I was trying to tell you, because this is a much smaller assignment, there's not as many places where you can go wrong. You can easily intimidate me by basically screaming at me to take off points if you don't do exactly what I tell you to do. All right? Okay, so let's go through the data. Make sure that your data is the way it should be. First of all, the mass of 4 pennies, since you are, I'm going to do the same video for CP chemistry, for my advanced chemistry class. So there's going to be some differences. For honors chemistry, since you're using the triple beam balance, how many decimal places should I expect to find? 3 decimal places. So can Alex, can you give me your data here? Okay, that's fine. Okay, so if you are in advance, I should only see 1 decimal place, but for you guys, I better see in 3 decimal places. Okay, so since you're dividing by 4, or in your case, Alex, by 5, 4 and 5 is not a measurement. So you can't just take and divide by 4 and have one significant digit. It's not a measurement. So you disregard that. So your mass of 1 penny should also be 3 decimal places if you're honors, 1 decimal place if you're advanced. Go. 3.3090. All right. So the volume of 4 pennies, whether you're advanced or honors, you should have been able to measure to 1 decimal place. So go, Alex. 1.9. And when you divide by 4, which once again is not a measured number, so you retain 1 decimal place, go. 0.38. You should have 2 sig digs. Okay. All right. So the density of 1 copper penny is, of course, going to be mass divided by volume. So what is that? 8.1, which, considering the fact that we're using graduated cylinders that can only measure to 1 decimal place, is not bad, since you know that the actual density of copper is 8.9. So that ain't bad. Okay, it's not great, but it's not bad. When you found on the other side of the experiment, you found the mass of the, in your case, 5 pennies. Everyone else is 4. What is it? Oh, who was your lab partner? Theirs was the solution that they didn't get the silver very fast, so you had to move it to Marty's. Okay, so you're gonna have to come in and bring in your 4 pennies. So using you as an example was a complete waste of time for me. No, that's okay. It was my time that was wasted. So how about, can anyone else take it from there? So I'm gonna need somebody else's data. London, thank you. Mass of 4 gold pennies. Oh my, okay. So a bunch of you are gonna have to come in tomorrow morning and finish this. Yes. And you also had 5 people in your group? Oh, so this is the data you need. Then you're going to need to come in before school tomorrow and do it. Okay, yeah, let's just go with this. So 15.557 divided by 4 is, or 5 in your case. All right, and the volume of 4 pennies, let's just assume that you got the same, because you probably should have gotten the same amount. All right, so what is 3 point, let's see, uh, volume of, no, should be 1.9. Yes, 0.38. So what is 3.111 divided by 0.38? What is it? Yes, 8.1, I'm sorry, 3.111 divided by 0.38. 8.1, so 8.2. Incorrect sig digs. All right, any questions so far? You should have something similar, thus proving that this ain't gold. This ain't gold. All right, so what happened here? Yes, it made brass. When you put it into that secret solution, you basically put it into an environment where there were a lot of zinc atoms just floating around. We created the gray powder in there. That gray powder was zinc. And the solution itself, so this gray powder down here was zinc. And the solution itself had zinc ions floating around in it. Now, I don't pretend to completely understand this reaction. This is really a high level reaction as far as understanding it. Basically, when you put the copper penny in there, the zinc was attracted, the zinc ions was attracted to the copper penny and stuck on the copper penny. So inside the solution, when it appeared to be silver, actually you had a copper penny with a surface of zinc, a very thin surface, like maybe a few atoms thick worth of zinc on the surface. So at this point, before you heat it up, you have a heterogeneous mixture, right? With mostly copper inside and a zinc coating. It is not distributed evenly throughout. Now, the other key thing about zinc and copper is that their melting points are very close together. So once you hit the melting point, I think zinc is first. Once you hit zinc's melting point, not too fast, not too far beyond that will be copper. So they basically are going to melt together. They will melt together so that once they start melting, some of the copper will bubble up to the top, kind of shoving the zinc away. So if you could see this under the microscope, you would probably see something like this, where you have splotches of copper here's our penny. So splotches of copper along with splotches of silver, zinc. Under a microscope, in other words, under a microscope, it would be so obviously heterogeneous. But when you're considering something to be homo or hetero, you don't really look for it in the micro scale. What you're observing is what you can see on the macro scale. In other words, what you can see with your eyes. With your eyes, did it appear to be one thing or multiple things? It appears to be one thing. When your eyes get a mixture of silver color and copper color, your eyes will interpret that as gold. Keep in mind that with a few exceptions, most colors that you can see, your eyes are seeing different colors beamed into your eyes. And your eyes take all those frequencies and interpret it in your brain, and your brain tells you, oh, that's red. That's not all entirely red. That color is not entirely red. It is a combination of reds and other colors because that's a different shade of red. Every shade of red is going to have different colors added to it. You understand? Okay, white, for example, as we will find out, is all the colors of the spectrum. So when you see something white, what your eyes are actually seeing is red, orange, yellow, green, blue, indigo, violet. Okay? Ever since you were a little kid, when your eyes saw all those frequencies, your parents programmed you to think the word white. So you're ruined right now. You are completely ruined. The reason why you say white is because your parents programmed you to say white. In reality, your eyes are seeing red, orange, yellow, green, blue, indigo, and violet. That's why when they were my kids were kids and we had the little white flashcard, I didn't let them say white. I made them say red, orange, yellow, green, blue, indigo, and violet. Well, I wanted to. My wife said, you're going to turn them into nerds and they're going to get picked on. She won, nevertheless, because of my DNA, they still ended up being nerds and they still got picked on. Okay? So, homogeneous or heterogeneous? Well, you look at it, it looks gold. Okay? If you had not determined its density, you would have thought it's gold. You could probably get a freshman. No offense, freshman here. You could probably get a freshman to be convinced that it is gold. Okay? Because what are we seeing? We're seeing a combination of coppery colors and we're seeing a combination of zincy colors. All right? Yes.
How does the zinc make the copper stronger?
Okay, well, first of all, not for this copper penny, because basically what you have is a copper penny with a brass covering. Okay, the way that copper is aligned, and this is getting into crystallography, which you won't deal with unless you become a chemistry major until your junior year. But basically, the way those atoms are aligned, uh, pure copper is the atoms are going to basically slide past each other pretty easily. But once you start getting zinc atoms, which are about the same size, once you start getting zinc atoms interlaced in between the copper, it doesn't allow them to slide past each other. So brass is not as malleable as copper or zinc by themselves. It interferes with the way they move around each other. Most mixtures are actually tougher than they are as uh, as pure substances. So, and of course, you can actually make it softer by having less zinc, or you can make it harder by having more zinc. So it really depends on what you want out of your instrument. That's why some instruments that musical instruments that require there to be a lot of bending and twisting and turning are probably going to have more copper than zinc. And if you just need it to be, you don't have to beat it into submission that much, then you're probably going to make it tougher, more zinky. So I want complete sentences. You realize that I just answered that question for you, right? And did I not just answer question number 2? Did a physical or chemical change? You need to ask yourself, did copper and zinc come together to form a new compound, or are they just existing with each other, living with each other? That's the question. If they are just coexisting, then that is a physical change. If they combine together to either share electrons or give or take electrons, then that is a chemical change. If this new substance that we call brass is something that is brand new with completely different characteristics and a completely different formula, that's a chemical change. If you can actually alter the combination, you can have more zinc than copper or more copper than zinc. That's just a physical change. Okay? You realize I just answered that question. Make sure that you give me this information back. What did we do to the penny to confirm or prove your answer to number 2? Okay? So, how were we able to prove quantitatively that the copper was not converted into gold? Rhetorical question. Billy's there going, yeah, go on, tell me. No, rhetorical. You need to be answering that question in your mind, Nicholas. If we do in fact have an alloy or a physical homogeneous mixture of two metals, what is the identity of this alloy? What two metals make up this alloy? I answered that. Was I not kind and generous and sweet? You see, my reputation is not founded on truth. Okay? Any questions? Yes.
Is alloy the name with the two metals mixed together?
Correct. That is what we call a mixture of two metals. For example, we discovered sometime not too long ago, like in the last 120 years or so, that a mixture of mercury and silver formed a very tough alloy that we can use to cover our teeth where there's been holes or pockmarks. So a tooth filling, it can either be a plastic alloy that eventually come off or a much more tougher substance, which they call an amalgam. So an amalgam is a combination of mercury and silver together. Any other questions? Okay.